try your hands on these problems on how to graph in trinomials when the leading coefficient is not equal to 1. Whenever you're ready, you can continue the video in these key points that are helpful for us to graph the functions, including the y-intercepts, the y-intercept mirror point, vertex, x-intercepts, and 2 additional points, so we can get better idea as to the general trend of the graph. Now that you have given it a try, we can get started in looking at the key points we have for part A. In this function h of x, the first thing we can identify is a y-intercept. Y-intercept happens at x equals 0, and h of 0 can be evaluated, and the constant term should be what's left. Therefore, negative 12 is going to be the y-coordinate of the y-intercept. So we can say the y-intercept is the point 0, negative 12, and I'm going to again highlight this just so it's easier to find later on. Then in order to find the mirror point across the axis of symmetry from the y-intercept, we want to find the vertex or the axis of symmetry first. So to do this, we are going to use a formula x equals negative b over 2a. This identifies both the equation for the axis of symmetry and the x-coordinate for the vertex. Now in this, we would have negative b, which would be 5, over 2 times a, which is 3. Altogether, we get negative 5 over 6 as the equation for axis of symmetry and also the x-coordinate for the vertex. Now that we know the x-coordinate for a vertex, we can go ahead and find its y-coordinate by plugging into the function. And since we have a fraction, you can expect the numbers to be a little bit messier, but that's fine for the process. We are just going to be careful with the calculation, but otherwise we know the steps to evaluate a function. Minus 12 over here, and that's how we're going to identify the y-coordinate. So here we would have 3 times 25 over 36 minus 25 over 6 minus 12. Take your time to do these arithmetic operations. Be careful not to make any mistakes along the way, because these numbers tend to have a lot of fractions. And here we can have some cancellation. 3 and 36 cancel out to have a factor of 12 in the denominator. And if we bring this down, this now becomes 25 over 12 minus 25 over 6. And in order to get a common denominator, we can multiply 2 on both sides in order to achieve the denominator of 12 of this fraction. And then we would have 50 over 12 here minus 12, which would be, again, identified to be over 1, and in order to get the denominator to be 12, we have to multiply 12 on both sides, which will lead us to 144 over 12. And calculating all this, we have 25 minus 50, which is negative 25. Negative 25 minus 144 will be negative 169 all over 12. Again, no need to rush through these arithmetic operations, even though I'm walking through the steps pretty quickly. And once you have this, that's going to be our vertex, negative 5 over 6, comma, negative 169 over 12. And later on, we'll definitely want to know what roughly negative 169 over 12 is equal to. So that'll be helpful for us to graph it on the coordinate plane. But for now, we are going to use this information to find the mirror point of the y-coordinate of the y-intercept. And for the y-intercept's mirror point, we say they're at the same height, so the y-coordinate should be the same as the y-coordinate of the y-intercept, and the x-coordinate should be double the x value of the vertex or the axis of symmetry. And here we have negative 5 over 6. Multiply this by 2 will be negative 5/3. Again, this is because if we had, say, negative x equals negative 5 over 6 as the axis of symmetry, we have the y-intercept as 0, negative 12. We can find that distance between the two is 5/6 over here, which is just the absolute value of the x-coordinate of the vertex, or the equation of axis of symmetry. And if we go another 5/6 on the other side in terms of direction, because we keep going to the left, we keep subtracting 5/6 over here, and this will eventually leave us to -5/6 minus 5/6, which would be -5/3, being the x-coordinate. And that's how we identify it. And the quick way is to just recognize the mirror point for y-intercept is going to have 2 times the x value for the vertex because of this equal distance. That's where the 2 comes from. And now that we have the mirror point, we can go ahead and move on to find the x-intercepts. To find x-intercepts, this uses the knowledge about factoring a function with leading coefficient not equal to 1. And if we want to do this, we want to use the AC method. That tells us a times c equals 3 times -12, which is equal to -36. That means we want 2 numbers with a product -36. And then we also want the sum to be equal to b, which is equal to 5. Again, take your time to go through the ordered pairs, and if you have given it a try, not ordered pairs, factor pairs of -36. If you have given it a try, you should find the 2 numbers that would work for us is 9 and -4, because they multiply to be -36, and 9 plus -4 becomes 5. And using this information, I'm going to go ahead and rewrite our function h of x. So my h of x is really equal to 3x squared. And then I have a positive 9, so plus 9x, -4, so minus 4x, and then minus 12. Once we have 4 terms, we can do factor by grouping. The first 2 go together, last 2 go together, connected by plus. From the first group, we have a common factor of 3 and also x. Make sure you factor out both constant and variable common factors. That leaves us x plus 3 inside the parentheses. And then we have -4x minus 12. Because it's a negative leading coefficient in the second parentheses, I'm going to factor out the negative sign. And also 4 is a common factor, so I'm factoring out -4 plus -4 just becomes -4 over here. And that again leaves x plus 3 in the parentheses. Once we do so, we notice the 2 groups both share x plus 3 as a common factor, and leaving us with 3x minus 4 over here. And that's a factored form of h of x. Once we have the factored form, we can go ahead and use the zero product principle and the fact that x-intercept happens when h of x equals 0. And if we set this to be equal to 0, that tells me x plus 3 equals 0, or 3x minus 4 equals 0. And I'm going to need a little bit more room. So that tells me x equals -3, or 3x equals 4, x equals 4/3. Therefore, the 2 x-intercepts are -3, 0, and 4/3, 0. Again, going ahead to highlight that. Lastly, we have a bit more flexibility to choose whatever points we want to work with over here. And I like to choose simpler numbers that haven't been used. That way we still have a good idea as to what numbers or what points are on the graph. So here I'm going to just choose h of 1, for instance. So for additional points, I'm going to choose h of 1, and if we just look at h of 1, these are just the coefficients we have. 3 times 1 is 3, plus 5 times 1 is 5, minus 12, which gives us -5. So I know the point 1, -5 is on the graph. And because of this, we want to do the same thing as before to find the mirror point. If I have 1, -5, and I know this point, or this line, is x equals -5/6. I first want to find the distance between my point and the line. That difference between x is going to be 1 and 5/6 over here, or 11/6. And that means that we need to go this much on the other side as well. And once we have this, we want to subtract 11 over 6 from negative 5 over 6. Again, because we're going further left. So negative 5 over 6 is our starting point, minus 11 over 6 becomes negative 16 over 6, or negative 8 over 3. This can be left as your scratch paperwork, but it's helpful to kind of see a visual to see the equidistance. And therefore, we know the other point we have is negative 8/3, negative 5. That's a mirror image of the point 1, negative 5. In the next step, we're going to go ahead and scale things on the graph. My axes, I notice that for the y direction I have a lot of negative values, so it's probably a good idea to leave more room on the negative side for my graph, and all the negative numbers are pretty far away from 0 as well, including negative 12 and negative 169 over 12, which is even further away. And then we can notice for the x direction we have a lot of fractions with denominator equal to 3 or 6. It becomes a decent amount of distance if you go every 6 boxes, so I'm going to go by every 3 boxes, being 1 on the x direction. So I'm going to take a minute and scale things based off this information. A scaled coordinate plane, and I'm going to go ahead and put all the points on. 0, negative 12 is right here as a y-intercept. Negative 5/3, negative 12, because I scale things as 3 boxes, being 1 unit. Negative 5/3 should be exactly 5 boxes to the left of the origin and go into negative 12. And negative 5/6, negative 169 over 12, we have to eyeball it a little bit. Negative 5/6 is right in the middle of this third box. Going down, negative 169 over 12 is just below negative 14, because I believe negative 14 is negative 168 over 12. So just ever so slightly, you can pretty much put it right there on the line almost. And then we have negative 3, 0 as the x-intercept, 4/3, 0 as the other x-intercept, negative 8/3, negative 5 as 1 point, again 8 boxes to the left of the origin. Negative 5 is right here, because on the y direction I just labeled each box as 1 unit, or the length of 1. And then lastly, 1, negative 5 will be right here. And once you plot all the points, do a quick check to make sure they are truly symmetrical along the vertex or axis of symmetry, and it forms a smooth curve. Therefore, we can connect all the points with a smooth curve as much as possible. And therefore, we get the graph of h of x like this. And whenever you're ready, we can move on to the next part for graphing again. For the k of x graph, we are going to do the same thing as before by identifying the y-intercept and the vertex first. Familiar with this already, we get k of 0 is equal to 8, so we would just get y-intercept is 0, 8. And then for the vertex, we are starting off with a formula, x equals negative b over 2a, which becomes negative of negative 42, which is what we have for b, and 2a, 2 times 10. And altogether, we would get 42 over 20. This can be reduced. You can reduce it even before you multiply 2 and 10 together as well. Here they share a factor of 2, so 21 and 10 over here. So the final answer will be x equals 21 over 10, being the x-coordinate for the vertex. And you can alternatively do the mirror point first at this point, because we know the mirror point is going to have the x-coordinate, which is twice as much as the axis of symmetry equation. So we would get 2 times 21 over 10, which is 21 over 5. And it's the same height as y-intercept, so y-coordinate is still 8. So therefore, we get the mirror point already. And the more painful process of finding the y-coordinate of the vertex. So k of 21 over 10, because we want to find the y-coordinate corresponding to this x-coordinate for the vertex. Therefore, we get 10 times 21 over 10 squared minus 42 times 21 over 10 and plus 8 over here. And once we do this, we are going to get some cancellation over here. If you don't notice, you can write this out as 10 times 21 squared over 10 squared without worrying about 21 squared for a minute. Minus here 42 times 21 over 10. There's not much we can do over here, so we actually have to eventually multiply this out. The 882 over 10 plus 8, we're going to leave it as is. The first term, the 10s cancel each other out, and you're going to get 21 squared, which is 441 over 10, minus 882 over 10 plus 8, and that gives us negative 441 over 10 plus 8. In order to get it over 10, we can multiply 10 on both sides, so that gives us 80 over 10. All together, we are going to have negative 361 over 10, if I did the math correctly. And once we have this result, we got the vertex, which is a very messy number. And once we have this, we can go on to find the x-intercepts. X-intercepts are done through factoring again. When we're doing factoring, make sure you check the GCF first. In this case, we see there's a GCF across the board of 2. That'll make the whole finding factor pair process much easier. Once we do this, 5x squared minus 21x plus 4 is what we have left. So now these are our new A, B, and C. With this information, I'm going to use the AC method. So I want the product to be equal to A times C, which is 5 times 4, or 20, and I want the sum to be equal to B, which is negative 21. Again, take your time to go through the factor pairs. In this case, we will eventually find the two numbers are negative 1 and negative 20. Once we have this information, I'm going to rewrite the original part inside the parentheses with the new linear coefficients. So instead of starting from k of x, I'm just going to use 5x squared minus 21x plus 4. Just focus on that. And that's equal to 5x squared minus 1x minus 20x plus 4. And once we do so, we are going to group them into two groups again, connected by plus. From the first group, just x is a common factor, leaving us with 5x minus 1. From the second one, again, the leading coefficient is negative, so I'm going to factor out the negative sign along with a common factor of 4. Once we do this, we have 5x minus 1 again. Taking out the 5x minus 1 in common among the groups, leaving us with x minus 4. And that's going to be the factored form of the part inside the parentheses. And now if we want to set k of x equal to 0, that's really the same as saying that 2 times 5x minus 1, x minus 4, is equal to 0. Using the zero product principle, there are three factors here. 2 cannot be 0, 5x minus 1 could be 0, or x minus 4 could be 0. So that 2 can essentially be divided away on both sides, because we know that's not 0. And that gives us 5x equals 1 and x equals 1/5. The other one gives us x equals 4. Therefore, the x-intercepts are 1/5, comma 0, and 4, 0. These are the x-intercepts we have. Again, looking back to all the points we have, most of them are there are some messy numbers along the process. So for additional points, I'm going to choose simpler numbers. My classic choice is letting x be 1. So for k of 1, we would just have the coefficients 10 minus 42 plus 8, which is equal to negative 24. I'm running out of space a little bit. And here we have negative 24. If I want to find its mirror point for 1, negative 24, remember the axis symmetry is 21 over 10, x equals 21 over 10. And this is greater than 1, so I know my point 1, negative 24 is going to be to the left of the axis symmetry. Now finding the difference or the distance between the two, we are going to get 11 over 10. That means I need to move another 11 over 10 in distance to the right side. Once I do so, I can find the x-coordinate is 21 over 10, which is the axis symmetry, plus 11 over 10, that distance, which gives me 32 over 10, can be reduced to 16 over 5, and therefore this point is 16 over 5, comma, negative 24. And here we can see clearly we have very, very negative values, so I'm going to adjust my coordinate plane a little bit to accommodate all the very negative values. But also on the positive side, I have a positive 8 to accommodate to fit in the y direction. On the x direction, I notice there are denominators of 5 and 10, and I don't have any super far away numbers, so I might go by every 5 boxes being 1, but I need to readjust my coordinate plane a little bit so I can fit all the numbers in and scale it based on this. So I'm going to just take a minute to do this, make this show up. Plane scaled over here, and we can go ahead and plot the points. 0, 8 is the first point, 21 over 5, 8, 21 over 5 is 21 boxes to the right of the origin based on how I scaled things, so it should be right on the edge of this screen, right over here, so along this line, and 8. And then we can find the vertex. The vertex is 21 over 10, which is just slightly above 2, be in the x-coordinate, so halfway in this box, and negative 361 over 10, which is negative, just below negative 36. So right here. And then we have the x-intercepts, which are 1/5, 0, and 4, 0. Again, I scaled the x-coordinate so that I don't have to eyeball as much. And the last 2 points, we have 1, negative 24, and 16 over 5, negative 24. So these points will be at 1, negative 24, and 16 over 5 will be 16 boxes to the right of the origin, just the next box after 3. And once we have all these points, again, you can check they are roughly symmetrical or along the axis symmetry. And then we can go ahead and connect all the points. This is going to be a little bit more challenging because my graph is fairly wide over here. And once you connect the graph with a smooth, nice curve, this is going to be the graph for our k of x in this case. And that's how we do it for trinomials when leading coefficient is not equal to 1.